Hi, 7th graders. This is Mrs. Fancher. I would like to welcome you back after winter break. I'm hoping that you had a nice, long, relaxing couple of weeks off. I'm going to be gone today and tomorrow, so please be sure that you have your computer charged, ready to go for the next couple of days. And also please be sure that you bring your own headphones if you wish to, that are corded, or you could use the blue headphones that we have in the classroom as well. You are going to be needing a note sheet next to you with your pencil, and you will see in the middle of your table that you have algebra tiles, little shapes, and we'll be working on those and using those throughout the next couple of days. Please be sure that you're working independently, not talking to your neighbor, so that everybody can get their work done, remembering that the note sheets will be used and can be used for your test, and it will be extremely helpful to see some of the examples on your notes that will also be on your test to be able to look and refer back to them. So at this time, if you could please look at the bottom of the screen, and on that sheep scale, how do you feel today? Go ahead and get started. First, I'd like to read what our combining like terms will be with what we'll be doing in the next week or two. So with mathematics, they can be used to describe patterns in the world. Scientists use math to describe various aspects of life, including how cells multiply, how objects move through space, and how chemicals react. Often, when scientists try to describe these patterns, they need to describe something that changes or varies. Scientists call the quantities that change variables, and they represent them using letters and symbols. In this course, you will spend time learning about variables, what they represent, and how they serve different purposes. To start, you will use variables to describe the dimensions and areas of different shapes. You will begin to organize the descriptions into algebraic expressions. So today I'd like you to, on your own, think how you can organize groups of things, how and what is the area, and what lengths can vary. So today's lesson, I would like to read how we are going to be simplifying our algebra tiles today. So it is talking about mathematics in science. Mathematics can be used to describe patterns in the world. Scientists use math to describe various aspects of life, including how cells multiply, how objects move through space, and how chemicals react. Often, when scientists try to describe these patterns, they need to describe something that changes or varies. Scientists call the quantities that change variables, and they represent them using letters and symbols. In this course, you're going to spend time learning about variables, what they represent, and how they serve different purposes. To start, you will use variables to describe the dimensions and the areas of different shapes. You will begin to organize the descriptions into algebraic expressions. What you can think of on your own is how can you organize the groups of shapes in front of you, and what would the area be, and what would the lengths be, or how would they vary? Again, like I said, we have provided you with a baggie of the algebra tiles in the middle of your table. At this time, if you could remove one of each size shape from the bag and put it in front of you. You will then take the time to trace around each shape on the paper on your note sheet. And once those are all drawn in that space provided on your note sheet, I want you to look at the different sides of each shape. On your own, which shapes have the same side lengths? Which ones have different side lengths? You can circle or you can highlight the lengths that are the same. Each type of tile is named for its area. In this course, the smallest square will have a side length of 1 unit. So its area is 1 square unit. Right here, 1. All of the sides around are 1, and that tile is called 1 square unit. This tile will be called 1 or the unit rate. Can you use the unit tile to find the side lengths of other rectangles? So yes, we can for only one of them. If you see that there is the same side length that matches right here and here, those are the same side lengths, those are all 1 long as the perimeter. This side is also 1 unit long. So yes, we would be able to use the unit tile to measure the 2 sides of the rectangle that is on the left of it. If the side lengths of a tile can be measured exactly, then the area of the tile can be calculated by multiplying these 2 lengths together. The area is measured in square units. For example, the tile below measures 1 unit by 5 unit, so it has an area of 5 square units. What if there is no unit of measure on the side? What will be the length? That side length will be called X. When a collection of algebra tiles is described with mathematical symbols, it is called an algebraic expression. Looking at the tiles that are on your paper, on your note sheet, I want you to use mathematical symbols, numbers, variables, and operations to record the area of this collection of tiles. We would like you to be able to write at least 3 different algebraic expressions that represent the area of this tile collection. What would be one algebraic expression that you could write that would contain all of the algebra tiles on your paper? Right now, I see one shape that is the largest, and I see it's named x squared. Then I see The next size shape is a rectangle, and those rectangles, if I count them up, I see 6 of them. So I would write down plus, I see 6 X's. Then I look at the third shape and I see unit tiles, and I see 8 of them. That is one way to write the expression. Another way would be to write them all individually, writing down that we see 1x squared plus these 2 x's plus 1x plus 2 x's and plus 1 more x. Then we could see that I have 5 plus 5 units and then 3 more, writing it like that. That's another expression. And a third way, we could write down that again, we see that 1x squared plus I see those 2 x's, and I see all the other x's. I could just say I see 1 more x plus 1 more plus 1 more and continue. All together, that would be 6 x's. And then I could say plus I have 8 ones. You could have written it many other ways. Again, this first way is the simplest way of writing it because it's less writing, and so it is called in simplest form, and that is where we want to be sure we head for all of these problems and have our problem or our expression look like that. Now, if you could look at the problem on the bottom of your page, you see another pile of algebra tiles. Take the time to write the algebraic expression of the pile of tiles that you see in front of you on your own. If we bundle them together, the largest shape is x squared. I will write that we see 3 of them, so 3 of those x squared shapes. If I then count the rectangles that are called x's, I see a total of 6 x's. So we would write plus, I see 6 x's. Counting the units, I see a total of 5, 10, 15, 16, 17, 18, 18 of them. That is your simplified expression, and that is your final piece of your notes. Now that your notes are completed, please put the note sheet into your binder in your notes section so that you'll be able to use it for your upcoming test. If you go to Google Classroom, your step 2 is having you clicking on a link for you to do a booklet and answering some questions, again, relating to our algebra tiles and combining those like terms. If you finish that, you then have your rest of your time to complete step 3, which is working on your homework, pages 1 and 2 in your homework packet. And please have that done before you walk into class tomorrow. Be sure that you're quietly working up until the bell rings. Have a great rest of your day. Bye-bye.